As well as simulation characters, it's possible to create props within Endorphin. A prop in Endorphin can really be defined as any character that doesn't have a matching simulation character, so these can be objects as simple as a football or as complex as a horse or a dinosaur. In this tutorial, we're going to create 3 different types of props and use them to populate the hall scene we made in tutorial 4, creating environments. So to begin with, we'll create the simplest of the 3 props, which will be a chair. We'll base it on a single joint and a mass object, and then we'll use several collision objects to flesh it out and recreate its shape. Prop characters, just like any other new character, are created in character edit mode. So let's go to the File menu, to character edit mode, and select New Character. And then in the New Character dialog box, under Standard Characters, select Standard Prop Character, and click OK. In the viewport, all we can see initially of the standard prop character is a simple sphere, but let's select that sphere and use the N key to open up the node view and take a closer look at the structure of this character. And you can see that it's actually structured in a very similar way to every other character in Endorphin. The topmost node in the hierarchy here is by default labelled reference character and has the standard character icon. This is represented in the viewport by a character cube just here. The reference character node has a single child, which is a joint, by default labelled root. That in turn has a single child, which is a mass object labelled root mass, which again has a single child, which is a collision object named root collision. Now we won't be needing this root collision object, so we can select it in the node view and hit the delete key to remove it. Now let's import an OBJ file as reference to build the shape of the chair around. So select the mass object in the viewport, use the I key to open up the file browser and navigate to Tutorial 6 Creating Props, which is within your installation directory. Then, ensuring that you have file of type set to OBJ files, select hallchair.obj and click Open. In the Import dialog box, just accept all the default values, and in the viewport you'll see your chair OBJ represented as a graphic. Now select just that graphic and using the Move tool, position it so that the sphere is just about at its centre, since this sphere is actually going to be acting as the centre of mass for this chair. Now we can select the mass object, and because the graphic is parented to that mass, when we move it, they'll both move down, and we want to position them such that the chair legs are touching the ground plane. You might want to move into front or left view to do that. So now let's start adding some collision objects to fill out the shape of this object and give it some physical presence. Now we want this mass object to be the parent of all the collision objects we create, and since parenting is done on creation in Endorphin, ensure that you've got this mass object selected before moving up to the main toolbar and selecting Create Box Collision Object. We can now move, rotate and scale this collision object so it matches the seat of the chair. I'm not going to spend too long doing this, but obviously the longer you spend, the more accurate your results are likely to be. So you can now move through creating collision objects for the other surfaces in this chair, the back and the legs, ensuring that every time you create a new collision object you select the mass object as the parent. And I'll pick this up again when I've finished creating the other collision objects. Once you've completed fleshing out the shape of your chair using collision objects, as I have here, and you can see them all here as children of the root mass object, we want to save this chair out as a new character. So go to the File menu, Character Edit Mode, Save Character As, and name the character Chair, and click OK. We're now going to go on to create a table which is broken into several pieces. We're going to do this by loading in an FBX file which has several joints. Each of these joints will represent a single piece of the table. So let's once again go to the File menu, to Character Edit Mode, and select New Character. This time in the New Character dialog we want to uncheck the Create Character Using box, because we're not going to be creating a simulation character. We don't want a standard prop character. We want to create a character from an existing FBX file, so check the Create Reference Character Using checkbox and navigate to the Tutorial 6 Creating Props directory, and from there select All Table Broken FBX. Click Open. OK that. And in the Import dialog box, select the root node from the Select Root node for import and click OK, leaving all of the other settings at default. Now this doesn't look much like a table at the moment, but each of these 3 sections here is one of the joints with associated mass objects. If we go over to the node view, we can see that under the single root joint object now, we have 3 other joints and a mass object. We're not going to need this long mass object, which is the child of the root joint, so let's select it in the viewport and click delete. Nor indeed are we going to need any of the collision objects which are associated with the mass objects for each joint, so we can click on those in the node view and hit delete. Do that for the second one. And finally, for table 03, mass object and its collision object, delete that. We don't need any of those collision objects because we're going to be creating our own. So now let's import an OBJ mesh to use as reference to build the collision objects around. So hit the I key, navigate again to Tutorial 6 Creating Props, and this time select Hall Table Broken.obj. Click Open. In the Import dialog box, accept all the default values and click OK. And in the viewport you'll see a graphic representation of the OBJ mesh. Now these pieces of table are quite large, and they're currently represented by small spherical mass objects. So we need to adjust these mass objects to give each table section, each of which differ in size, an appropriate mass. In that way we can get a pretty accurate mass distribution for the different parts of the table. So let's move over to the node view, and under reference character, then again under root, select table 01, mass, and you can see it now selected in the viewport. And the first thing we're going to do is move over to its property view and change it from a geometry type of fill to a type of cuboid. And you can see now in the viewport that that mass object has changed to a small box. And we can now go on to scale and move this so that it represents the mass of this large section of the table here. And remember that this represents the mass of this large section of the table here rather than its collision surface, because what we're currently working on is mass distribution rather than collision properties. And that's beginning to look about right. Now I'm going to go on and do exactly the same thing to these two mass objects here and here, changing them into cuboids, and then I shall scale and position them to represent this section of the table and this section of the table here. And I'll pick it up again when that's complete.